Hello everyone. In the last video we saw the if-else statements and the relational operators, and in this video we will extend the if-else statement or conditional statements. First, if you remember, in the last video we handled the double conditional situation. What is that? If as equals to hello is the first situation and else is the second situation, which is as not hello. What if we need to handle multiple situations at the same time, multiple conditions at the same time? Of course we can do another if statement. Let's see. Let's say a is 5 in here and s is equal to hello is not enough for me. I want that a is less than 10. I need to check it. I want it. So I can write another if statement in the first if statement. Let's say a less than 10. And right now, if my string is hello, it will run this code. And if my a is less than 10, it will run this command. Okay, let's try it. Let's write my script. As you can see, I am running it, but a doesn't change. Why? Because I always setting 5 in here. Now I delete it and I change my s with hello. Now I click run. As you see, a increasing, and a is 6 right now. 7, 8, 9, 10. It stopped. Why? Because I had another if statement in here. And is there any other way to handle these situations together? As you see, I have a condition in here. I have another condition in here. I can merge it. I can merge them. How? By using logical operators. What is the logical operators? These were relational operators. And here is the logical operators. The logical operators are and, or, not, and exclusive or. And there's a short circuit ones, which is double ampersand or double vertical bar. And we will use ampersand for logical and. We will use tilde for not. We have already used it. And we will use vertical bar for logical or. We will use XOR function. This is not an operator. This is a function. And we have all and any functions. We will see in this course. Okay, let's try it. Before go to script, I can clear here. I cleared everything right now. Let's say a is 5, b is 6, and C is 7. And if I write here A less than B, it will return true. And if I write here A less than C, it will return true too. And what if I want to merge them in a one condition? What should I do? I need to use AND operator. Why? Because AND operator requires that both of them are true. If both conditions are true, the AND operator will return true. If one of them is false, the AND operator will return false. For example, 1 ampersand 1, which means 1 and 1. It will return 1. 1 ampersand 0, it will return 0. 0 ampersand 0, it will return 0. 0 ampersand 1, it will return 0. The only case is returning 1 is both of them should be 1. Okay, let's write in the A, B and C on. Okay, A less than B and A less than C. It returned true. Why? Because the first condition is true, the second condition is true too. The both of them true, that means the result will be true. And we have an OR statement. To use OR statement, we can use vertical bar. 1 and 1 will be 1. Why? Because OR statement, if any of the statements, if any of the conditions are true, is true, then the result will be true. 1 or 0 will be 1. 0 or 1 will be 1. The only case that OR operator will return 0 is both sides are 0. None of them is 1, that means the result will be 0. Okay. And we can use that logical operator in script. Instead of using two if statement, I can use in here an ampersand because I want them both be true. And A less than 10. Now I will delete this and okay. Let's run it. As you see, A is changed. Why? Because S is hello and A is less than 10. It changed again. Right now it decreased. Why? Because if this condition, and here if is merged condition, is not true, then the else statement will run. And in here, my S were hello. It's okay, it's 1. I have an AND operator and then I have an A less than 10. My A was 10. So this statement, this condition is false, and because we were using AND operator. That means they both should be true to return true. In this case, A were 10, this will return false, and so this merged condition will return false. That means this if statement don't work, my else statement will work. So my A became 9. If I run it again, my A will be 10. If I run it again, will be 9. 10, 9. Why? One of them, my A less than 10, and one of them, my A is equal to 10, not less than 10. Let's see the AND and OR operators in the command window in detail. Let's clear our command window. Let's create a matrix or array. An array is equal to 1, 2, 3, 4, 5, 6. I have an array. Let's say A is less than 5. Not A. My ARR is less than 5 will return a logical array. Okay. If I use this and ampersand ARR is greater than 2. This time it will return the merge of them. How? It will check each element of that array is less than 5 and greater than 2. First of all, 1 is less than 5, it's true. But 1 is not greater than 2, it's false. And the result of that AND merge will be false because I used AND. 2 is less than 5 but not greater than 2, then the result will be false. 3 is less than 5 and greater than 2, then the result will be 1. 4 is less than 5 and greater than 2, my result will be 1. And 5 and 6 are not less than 5, so the result will be false. Why? Because I have an ampersand. Okay. Let's use an OR operator in here. If I use OR operator with the same conditions, my all elements will return true. Why? Because I have 1, 2, 3, 4, 5 and 6. All of them either less than 5 or greater than 2. For example, 1 less than 5, then the combination will return true. 2 less than 5, 3 less than 5, 4 less than 5, 5 is not less than 5. This condition will return false, but I have an OR operator, then I can check this one. So 5 is greater than 2, then the combination of these two conditions will return true. Why? Because one of them is true, so the 5 element is 1. And at the same way, 6 is not less than 5 but it's greater than 2. That means the result will be true. And okay, and let's try to convert any numbers to logicals. It sounds a little bit weird, right? Let's check it. We have array, and we want to convert this array to a logical array. So we can use a logical function, and I can give my ARR variable as a parameter, and now it returned all of them is 1. Why? Because the logical function will return 1 or 0 for each element of array. And if my number is not 0, then it will return 1. If my element is 0, then it will return 0. In this array, I don't have 0, so it returned all of them 1. Let's change array 2 to 4 is equals to 0. Now I have 1 0 0 0 5 6. If I use the logical ARR command again, now this time I have 1 0 0 0 1 1. Why? Because the logical will return 1 for non-zero elements, return 0 for zero elements. Okay. And in here I have an XOR. If you don't remember XOR, I can say if you have 2 ones, it will return 0. If you have 2 zeros, it will return 0 again. But one of your elements is 1, it will return 1. And if you have one element 1, but the 1 is the other element, it will return 2 again. If the elements are different, it will return 1. If the elements are same, it will return false. This is basic mathematical logical operations. But this time we didn't use an operator, we will use that XOR function. So I have one array and I want to create another one. ARR2 is equal to 42408 and 3. I have 1 by 6 array. So I can use both of them in an XOR function. The first one is ARR and the second one ARR2. And the result will be 0 1 0 1 0 0. Why? Let's write ARR and ARR2. And if I use any logical operator or any logical function, and if you use on that operators or on that functions and numerical variables, Matlab firstly Matlab will convert them to logical variables. So the logical array and logical array 2. Matlab will first convert them to logical variables. So after conversion, right now the logical parameter will do its work. What is it? We will use XOR 1 1. They are same, so XOR will return 0 like that. First one is 0 and 0 1. They are different, so it will return 1. 0 0. They are same, it will return 0. 0 1. They are different, it will return 0. 1 1. Same, it will return 0. 1 1. Same, it will return 0. Let's write it, and let's write XOR 2 ARR and ARR 2. See, they are same. And in here you can see that there is some orange warning in here. When both arguments are numeric scalars, consider replacing ampersand with double ampersand for performance. What does it mean for performance? If you use single ampersand or single vertical bar in any if statement, if in anywhere, it will check the first statement is true or not. Let's check. S is hello. Let's check it. Yes, S is hello. Then here is true. Okay. Then it will check the second one. Is A less than 10? Let's check it. A is 9. So it's true. Then it will execute here. Okay. What if I use double ampersand here? No. Let's let it stay 1 ampersand. But this time I will change hello to hella. Now, first I need to check here. And I checked as is not equal to hello. Then I need to check here. Here is true. Here is false. Then result will be false. But I don't need to check the second one. Why? Because I use AND operator in here, as you see. And the AND operator will return false if any of the conditions is false. So the first one, if the first one is false, then the result is always false. But if you use single ampersand here, Matlab will evaluate the second one too. This is why it writes replace single ampersand with double ampersand for performance. Because if you don't use double ampersand, Matlab will always evaluate the second condition too. Then let's change it. Right now, Matlab will see that the first one is false, then doesn't evaluate the second one. Why? Because we used double ampersand. It's really nice. If I use AND operator in here, right now, it's the same way. Right now, S is not hello. But this time I used OR and double OR, and I need to check here. Why? Because one of them is 0. The situation that one of them is not 0, doesn't mean anything when you use or. Why? Because if any of them is 1, it will return true. And to make it return false, the both of the conditions should be false. So Matlab need to check the second condition too. But if my hello was hello, then right now as is hello, it says yes, it's true. Then Matlab will see the double vertical bar, which means or. Then Matlab don't evaluate the second one. Why? Because one true condition is enough to return true. Yes, this is the single ampersand, double amp. This is the difference, single ampersand and double ampersand, or single or double, single vertical bar or and the double vertical bar. And here we have all and any functions. In the description says all determine if all array elements are non-zero or true. What does it mean? Let's check in Matlab. Okay, let's say logical array is equal to my array less than 3. Now I have a logical array, which is the fourth one is 1 and the last one is 0. And if I use all with LA, which is logical array, it will return 0. Why? Because all use AND operator. If one of the elements is 0, it will return 0 because all use AND operator. And we have any operator too. If I use any function and the LA as a parameter, it will return true. Why? Because any use or operator, which means any element of the LA is true, means that the result will be true, because or says that any of the conditions is true, then the result will be true. So I can write here all ARR greater than 5. But first let's print ARR here, and all ARR greater than 5. The result will be 0. Why? The all elements of the array is not greater than 5. But if I use any LA greater than 5, not the LA, ARR. Now the result will be 1. Why? Because my array has 1, 0, 0, 0, 5 and 6, and this 6 is greater than 5, so the result will be true. Why? Because any of them is provide that condition. But for all, it's not. Why? Because for in all function, all elements need to be provide this condition. If any of them don't provide this condition, the result will be 0. Okay, and let's go back to our script. In here, we checked this conditions for two statements, for two cases. One of them is increment by 1, one of them is decrement by 1. What if I have more statement? For example, this time I only will use A. Right now, if my A is equal to 1, then I will increase my A. And right now I can use else if, which means my A is not equal to 1, then I can use another if in here. If A is equal to 2, then I can use this one. And what if I want to use the condition that A is equal to 3? Then I can use in here else if my A is equal to 3, and I can write any comment here. A is equal to A plus 2, and another and for the previous if. Right now I handle 3 conditions. 1, which is A is 1, 2, which is A is 2, 3, which is A is 3. Let's run. My A is 9 right now, and let's delete this code line 2. Okay, let's run it. Nothing changed. Why? Because my A is 9, so my A is not equal to 1, then it doesn't work here. Else, yes, else is okay right now because my A is not equal to 1, so else will work. This code will work right now. In here, if A is equal to 2, no, this is false, so that means else will work. So in this else, my if, I have another if. A is equal to 3, no, my A is not equal to 3, so it doesn't work here, so it doesn't do anything. If I change A equal to, and if I run my script again, you will see that A is changed. A was 2, and in here the condition which A is equals to 2, I changed my A. I decreased my A by 1. But if you see that I have lots of if else if else statement, and the alignment is different. Instead of this, I can use another keyword which is Elsif. So I can use else and if together, and then that means I don't need lots of and. Now this code will do same thing with the previous one. Let's run it. My a is become 2. Why? Because a was 1 and a is increased by 1. If I run it again, it will be 1. True. 1, true. 1, 2, 1, 2. Why? Because when a is 1, I increase a. When a is 2, I decrease a. So a is going between 1 and 2. And I can use another structure instead of if, else if, or if else structure, which is switch case structure. Switch. This switch case structure will work the situation like this. I have an variable and I am doing my jobs according to that variable. If that variable is 1, then I am doing this, and if it's 2, I am doing this, and if it's 3, I am doing this. So I can use a switch case structure. Why? My job is dependent on the A. So I can use switch A and case 1. A equals A plus 1. Case 2. This time I will change A equals A plus 2. Case 3, then A equals A minus 1. And my switch case structure. And right now I can delete this one. Let's see what will happen. My A is 2 right now, and if I run here, my A become 4. Why? Because in the case 2, my A is increased by 2, so my A become 4. And what if my case is not any of them? So I can use another keyword here, otherwise. Otherwise, A equals to A minus 2. And this otherwise will be executed when any of them is not true. In this case, my A is 4. If I run that script, my A will be 2. And I want to change my A to 5 in here. So let's run it. my A was 5. That means in this switch case structure, here is not working. Why? Because my A was 5 and it's not 3, then the otherwise will work. Then my A will be decreased by 2. So my A becomes 3. And if I run it again, my A was 3. So in this case, I checked A for 3, and this case will work. My A is decreased by 1. If I run it again, right now my A is 2. I click run, then this case will work because my A was 2. I changed the A by increasing by 2. Right now my value become 4. And this is the switch case structure. This can be used for if-else if you use a single variable. That variable can be array too, can be string too, but there should be only one variable. Okay, and let's continue with logical indexing. Let's delete here, let's save here, and let's go to command window. Let's clear everything. Let's clear the command window too. And the logical indexing. If you remember, if we use arrays or matrices, something like that, 1, 2, 3, 4, 5, 6, I can reach the elements by indexing. For example, A1. Sorry, it's not A, it's ARR. For example, ARR1, it will return the first element. And if I use 1, 2, 4, it will return the 4 elements. And if I use 1, 2, 6, it will return first, third, and fifth elements. Why? Because there is a colon operator in here, and it will start from 1, then it will increase by 2 and end on 6, and it will get 1, 3, 5. I can write it like that, not like that. I can write here an array like 1, 2, and 5. Right now it will return first, second, and fifth element. Let's change our array by adding 1. Now my array, I need to assign it ARR plus 1. If I write again the indexing, I want the first, second, and fifth values. Right now I have 2 as a first variable, 3 as a second variable, and 6 as a fifth variable. And in logical indexing, we can use logical arrays instead of double arrays or instead of number arrays. Let's check how we can do it. For example, when I write logical array equals to a is greater than 3, sorry, it's not a again, logical array is equal to ARR greater than 3. Now it will return 1 by 6 a logical array. Okay, that means the first element is not greater than 3, second element is not greater than 3, but the rest of them is greater than 3. So if I use ARR and if I use LA as an index for ARR, it will return the only true variables, only true indexes. For example, the first is false, so it will not return first. Second is false, it will not return second, but third, fourth, fifth and sixth are true, then it will return that 4 element. Let's see it. And this is third, fourth, fifth and sixth element. As you can see, I have all of them. And in that logical indexing, you can filter your arrays. For example, I have an array and I only want that the elements are greater than 4 in my array. So if you use this, it will return 5, 6 and 7. Why? Because they are the only ones that greater than 4. What about matrices? M is equal to 3, not 3, I will create a matrix 3, 4, 5 and 6. Now I have a matrix. If I use the same thing in here, M, and I want that M is greater than 5. Now it returned only 6. And what if I write not 5, 4? Now it will return a column vector. But there's something weird. My matrix was like this. 5 and 6 were in the same row, but the result is column vector. This is why when you write this condition, when you write this comment, Matlab always return a column vector. Why? First Matlab converts your matrices to a column vector by using this. If you write M and if you give a column as an index, it will return to a column matrix, column vector. Let's write it is column vector is equal to M and column. It will return a column vector. Then Matlab implements your logical indexing, which is column vector greater than 4, and the result is 5, 6, and the result is column vector. And also you can change your variables. with logical operators. How? Let's say I have a matrix. I will use a built-in function rand, but this time with n. Let's say 3 3. This n means that it will return also negative results. Now I have a matrix which is random, and right now I want to change that the negative values with 0. I want to make the negative ones 0. So I can use m as an index. I can use m is greater than, not greater than, is less than 0, because I want the negative ones 0 is equals to 0. As you see, I choose the negative ones in here by saying m is less than 0, and I make them 0. And let's try to do that. Let's change the greater than 1. Let's change the elements that greater than 1 with 99. And I can say m, and I can say m greater than 1 equals 99. After this, you can see that here and here are changed. Why? Because they were greater than 1. The first one was 1.8, the last one is 3.5, and these are the logical indexing. And this is the end of our video, and see you in the next video. Thanks for watching. Bye.